I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 30th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see remnants of a weak gale producing 2-foot seas in the central South Pacific, and a more robust system, but still not particularly strong in the Tasman Sea, producing 28-foot seas aimed northeast. But as of right now, the pattern appears to be quieting down. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, or a push in the southern branch of the jet to the north. And I'm looking for the southern branch of the jet, and that is all there is. Literally no energy at all. You can see all the energy is up here in the northern branch, but that's not really the branch of the jet that supports storm formation. It normally runs somewhere down around here, and you see there's no energy of any magnitude. Was it 60 knot winds south of New Zealand? And then the jet kind of wakes up over the southeast Pacific, but it's not forming a trough. It's pushing down into Antarctica. That does nothing to support gale formation. What we want to see is the jet southern branch lifting to the north. What that does is help create a counterclockwise flow aloft, and that also manifests itself down to the surface. That creates winds. Winds, of course, generate seas. Seas, if they're high enough, as they propagate away from the fetch area, turn into swell. Swell, when hit your beach, turns into surf. So, as of right now, there's literally nothing in the upper atmosphere that would support gale formation. That's a pretty good indicator of where we're heading. Monday, much the same thing. Tuesday, some wind energy starts building under New Zealand at 120 knots, but watch this. It starts pushing south, and the ice line is somewhere right around here, deep 60s, so almost over the ice line. A bit of a trough right here, but notice the jet is also pushing hard south here. So again, no real support indicated. As we're into Friday now, still the jet, at least it's finally waking up a little bit, and has winds in the 110 knot range, and almost a trough trying to organize in the far southeast Pacific. But as we get into Saturday, the jet finally redeveloping, but way down south, doing nothing to support gale formation. Full-on ridging pattern over Antarctic ice by Sunday, and that's the end of the picture. So literally nothing indicated in the jet stream that says we're going to have a gale over the next 7 days. So let's go down to the surface. Look at surface level pressure, surface level winds. Yes, there is a gale present, 960 millibar low, generating 30 to 35 knot winds, but that's not a whole lot. This is part of a previous larger gale that was further north. We'll get into that in a minute. But this is 30 knot winds, 35 knot winds will generate maybe 12-second period swell. That won't even make it won't survive intact even up into California. This might do something for Peru and the French Polynesian Islands, but that's about it. We know there's a gale over in the Tasman Sea producing 35 knot winds aimed to the northeast. This is and generating 28-foot seas. That certainly could generate some small swell for, we'll say, the south shore of Hawaii, but pretty filtered by the islands up here. And that's about it. As we get into Monday, this system fades out, both systems pretty much gone, and you kind of can guess where we're headed from here as we get into Wednesday. Something trying to organize here, something trying to organize here, but watch this. The main one just falls straight south, the other one vaporizes, and literally no swell producing fetch from either of those is expected. The same sort of deal as we get into Saturday. Any activity falling down to the southeast and not doing anything. Then we get into Sunday, same thing, and we're 180 hours out, and just literally no meaningful gale production is forecast. So let's go take a look at the wave models. We're going back to Monday, the 24th of May, so almost a week ago. A small gale did develop down here in the, we'll call it the southwest Pacific. Tiny energy, maybe radiating up towards Hawaii, but not a whole lot. And then what did happen is another system developed here in the upper reaches of the far southeast Pacific. This was on Wednesday, Thursday last week. Seas 38 to 39 feet. And this well-positioned north system is in, or was in, the Southern California swell window and the Northern California swell window. And the further north it is, well, it means less travel distance to get to California, meaning less swell decay, meaning better odds of actually some rideable surf resulting. And then on Thursday, that system pushed out of, well, that's still in the Southern California swell window, about 118 west, something like that. That's where, we'll say, trestles and those areas are. And continued little fetch in here. Most of this aimed at Peru, but sideband energy on Friday, probably radiating north from it until about Friday night, and the whole system pretty much fell apart. And this is where we are right now. Let's look forward. So here we are. All that's left is remnants of what was the north position storm, and then the system in the Tasman Sea. All of them fading out, and we're into Tuesday. We're just blasting through this because we already know the outcome. Yes, there is a system over here falling southeast. Ice line. Oh yeah, let's examine this real quick. Up to about 64 south here under New Zealand, and then further south down around 68 south, something like that. And that will slowly be creeping north as winter sets and builds in further in the southern hemisphere. And what that means is less area to support storm development. The storms have to be positioned pretty well north to get anything. Given the way this summer has worked out, everything's been in the southeast Pacific and pretty far to the north. Not a whole lot under New Zealand. So it doesn't seem like it's too much of a concern, at least the way the trend has been going. We're into Sunday. We're a week out. Literally nothing. So no swell production forecast for the next week in the southern hemi. That said, let's take a quick look up north. We're going back to Wednesday, May 26th. A little gale did develop on the date line with seas in the 27, did we get higher than that? 28 feet for a nanosecond on Thursday, and then fading from there. Swell is in the water, pushing towards Hawaii. We're not talking big swell, 2 foot or 2.5 feet at 13 seconds or something like that. Should be arriving today, this evening, but probably more so Monday, Tuesday, Wednesday. I mean, actually, and you can see energy lingered up here into Saturday and even Sunday. Even into Sunday right now. So there is a considerable amount of, we'll call it wind swell, but it's got underpinnings and ground swell for the bulk of the coming week for the north shore of the Hawaiian Islands. Then looking for wind swell potential. On Sunday, we have high pressure, the typical summertime pressure gradient setting up. High pressure here, heat low inland, tightens up the isobars between the low and the high, generating wind. Also, obviously, broad area of low pressure in the, we'll say, the far western Gulf of Alaska. That is what's going to generate that wind swell we talked about for the Hawaiian Islands. Right now, we're focusing on this more traditional summertime wind swell thing. Yes, wind swell being generated for California, nothing too huge. Nothing out of the east, really, for the Hawaiian Islands. We're just looking at trade wind setup. Again, northwest winds, 20-25 knots on Monday over northern California. That's good for wind swell down into central California. Then that sort of fades out on Tuesday. No real meaningful trades east of the Hawaiian Islands. You want to see a big high-pressure system here to drive the trades, and we're not seeing that, which is actually kind of nice for a change. As we get into Wednesday, Thursday, notice a low forecast here for the Gulf of Alaska. We'll keep our eyes on it. We don't really believe that's going to happen. No winds of any meaningful nature off of California, Hawaii, meaning no real wind swells. Thursday, Friday, nothing. driven by this low. And then here you go. Here's high pressure, 1028 millibars, setting up on Friday evening. And once this low gets out of the way, there you go. There's your wind swell starting for exposed east shores of the Hawaiian Islands, and then building off of California in time for the weekend. Saturday, 35 knot north winds along the California coast into Sunday. That's wind swell and fetch the whole way over to the Hawaiian Islands. So wind swell for both California and Hawaii once we get into next weekend. Literally no precip forecast for California, no snow forecast per this dashboard here. What we're really looking at is snow levels. Anyone hiking out on the JMT, Pacific Crest Trail, that sort of thing. Snow levels relatively high, starting at 12,000 feet by the first, Tuesday, in excess of 14,000 feet and staying that way into about the 7th of June, then coming down a little bit. Still no precip forecast, just colder temperatures at elevation. So pretty much the end of any hint of winter or even spring, full-time summer situation. Snow melt well underway, if not well past its peak. It's almost dry at most of the resorts, and just patches of snow remaining. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and El Nino, La Nina? What's it going to be? As usual, we start by looking at winds on the equator. We're looking for the presence of the active phase of the MJO, the Madden-Julian Oscillation. There is two phases to it, active and inactive. The inactive phase we're not interested in. What that does basically is set up high pressure over the Pacific and does nothing for swell generation or for Kelvin wave production, which in turn is what pushes us towards El Nino. What we want to see is strong active phases of the MJO. The MJO travels from west to east around the planet. When the active phase moves over the Pacific, and it takes about 3 to 4 weeks to traverse from the West Pacific to the East Pacific, it can reverse trade winds. And when trade winds are reversed in the Pacific, that imparts energy to the jet stream. It can help move warm water that's in the West Pacific to the east in the form of a Kelvin wave. And if you get successive active phases of the MJO, well, one, for sure that helps promote storm production and swell production, both in the north and southern hemisphere, depending on what season it is. But it also can help usher in El Nino by taking warm water in the west, pushing it to the east, and reducing trade wind speed across the entire equatorial Pacific. And that sets up a host of other events that can, especially in winter months, make for devastating weather, especially along the U.S. So right now, we're looking at data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here. This is the West Pacific here. That is New Guinea. This is the equator right there. We're just looking at the arrows here. The arrows indicate wind speed, relative wind speed, irrespective of what time of year it is. The longer the arrow, the stronger the wind. So pretty strong east trades in the East Pacific, pretty strong east trades over the Central Pacific, and pretty strong east trades over the West Pacific. The Kelvin wave generation area, this far area from 170 west, 5 degrees north and south of the equator, right in there. Of course, when you get the active phase over here, that can reverse the trade winds, and that can lead to the series of what we consider positive conditions that can support storm formation, swell production, and other good things. But it is anomalies, the difference from normal for this time of year. So yeah, the winds are strong out of the east, but they're always strong out of the east this time of year. You look at the arrows, and they're like, well, not really going anywhere, just 5 degrees north and south of the equator. So that means trades are pretty much normal here. Maybe a little bit stronger out of the east in the Central Pacific, and a little bit stronger out of the east in the Kelvin wave generation area. That pretty much means that some sort of neutral to maybe inactive phase of the MJO is in play over the Kelvin wave generation area. Not what we want to see. We want to see the active phase over here. So let's dig for more clues, see if we can figure out what's going on with the MJO. So this is kind of a funky chart, but it shows the east-west component of the wind over the whole planet from 0 degrees, which is like over England, to the date line, which is so over the Indian Ocean, to the date line, over the Pacific, over the Atlantic, back to 0. All right, the blues are easterly anomalies. Consider that inactive phase of the MJO, and you see time going down here. The reds are westerly anomalies. That's what we want to see. So you see back in May, we had a lot of blues, a lot of easterly anomalies, inactive phase of the MJO. It migrated to roughly the date line right there, somewhere in mid-May, and has been holding there, consolidating, getting smaller, right on the date line. The far west Pacific starts about 135 east, so right about here. And then you see westerly anomalies started building about May 21st and have been solidifying themselves. They're supposed to take a little break over the next 2 or 3 days and then come back, but only filling half of the Kelvin wave generation area with easterly anomalies over the other half. So it's sort of a mixed bag right now. Sort of looks like the inactive phase of the MJO over the East Pacific, Central Pacific to the date line, the active phase of the MJO, and it's that west to east motion. So that would be like the inactive phase of the MJO. This would be the active phase of the MJO, but getting stalled somewhere around halfway through the Kelvin wave generation area. We really want to see these reds just blast on through and continue the whole way across the Pacific into the Atlantic, but it doesn't look like that's going to be the case, at least for the next week. So let's go out 2 weeks, and this is the statistic model, and this is not looking at winds, but the MJO has multiple components. It can affect the trades, it can affect precipitation, and it can affect, if it affects precipitation, well, you got to have clouds to have precipitation. So that's what this guy is looking at, is the presence of cloudiness or outgoing long wave radiation. That is sunlight reflectivity off the ocean surface. The blues mean less sunlight reflectivity, means clouds. The yellows and oranges mean more sunlight reflectivity, no clouds, high pressure, the inactive phase, the MJO. According to this model, virtually, where are we? South America, Central America, Hawaii right there, New Guinea there, the Philippines, Australia, equator, 0 right there. Okay, Kelvin wave generation area roughly right here, and this is 4 panels, 5 days each panel, going out 15 days. So currently, basically nothing going on, nothing going on, nothing going on, nothing going on. Now the dynamic model is a little bit more interesting here, and we'll try to keep the last frame of the statistic model in the picture here as well. So there we go. All right. So the dynamic model, the GEFS model, GFS ensemble model suggests, pretty much the same thing as the previous model, but starting 6 to 10 days out, the active phase of the MJO, cloud cover starts building over the Kelvin wave generation area, continuing building 2 weeks out, suggesting the active phase of the MJO setting up, while the inactive phase of the MJO stirs in the Indian Ocean. And digging a bit deeper for those two models, so this is the statistic model, this is the dynamic model. What are we looking at here? Well, this is what they call a phase diagram chart. The MJO moves from west to east, from the Indian Ocean to the maritime continent, over the West Pacific, over the East Pacific, under the United States, over the Atlantic, over North Africa, back to the Indian Ocean. These are dates, so what is this? This would be May 1st, 2nd, 3rd, and what is this? April dates. Okay, where the MJO has been. So it was pretty moderately active in April in the West Pacific. In May, it ended up over North Africa into the Indian Ocean, sort of collapsed there. The active phase right now is in the West Pacific. But if it's inside this circle, it's considered extremely weak. If it's like out here, extremely strong. So what you want to see is the heavy dot. That's where we are right now. You want to see that heavy dot like right up in here. But it's not. It's in the right sector, but just very weak. And these 3 different colored trails are the forecast track per the statistic model. Basically, active phase stuck in the West Pacific, but exceedingly weak. Now, the dynamic model paints much the same picture, but shows the active phase a bit stronger, outside of the circle just barely, still in weak category. And these are other potential, tracks here, but you get it's not just one prediction. It's multiple predictions. They sort of sum them together, and you get this kind of for the next 2 week picture of the active phase in the West Pacific, but weak. So this is the favored outcome as compared to the statistic model. Then there's the upper level model. This is for sure a statistic model, okay, and it depicts potential for rainfall. All right, so what are we looking at? 8 different panels. I think they're 5 days each panel. South America, Central America, the equator right there at 0, right? New Guinea there, Australia. So Kelvin wave generation area right there. We want greens. Favorable for precipitation in the Kelvin wave generation area, meaning the active phase of the MJO. Today, supposedly that's happening, but it's very weak and forecast to push over Central America through about June 23rd, while the yellows and oranges are dry air. The inactive phase of the MJO sets up about June 6th in the West Pacific, makes its way across the Pacific, and then somewhere in end of June, June 23rd, 28th, another active phase sets up and starts making its trek across the Pacific. So you can see active phase, weak. Inactive phase, stronger and moving from west to east. Then active phase, moving from the Indian Ocean over the maritime continent, this area, Bali, that area, into the Central Pacific. So for sure, there's a wave pattern, if you want to call it that, and it moves in phases across the Pacific. And it is these active phases that we're very interested in for the aforementioned reasons. All right, let's go out a month. Let's look at winds. This is, again, that east-west component of the wind. We want the west component. And you can see here, in fact, this is a pretty good illustration right here. Okay, so this is the whole planet on one chart, 0 to 180. That's the date line, 180. Kelvin wave generation area, West Pacific starts about here, 135 east, goes the whole way up the chart. Kelvin wave generation area ends here at about 170 west, the whole way up the chart. And the Pacific ends at, about 80 west, so somewhere over about here. All right, so back in March, early April, the dark heavy line is the active phase of the MJO. Reds are westerly anomalies. You could see it pushed across the Pacific from the Indian Ocean to the Pacific, over the East Pacific, into the Atlantic. And also notice this. These are tropical systems associated with, and typically when you get the active phase, because it produces west winds, that spins up low pressure systems, and that feeds tropical development. You notice then, but not limited entirely to the active phase of the MJO, because we see one stray one here back in mid-May. All right, now here's the next active phase of the MJO, and you also see it does the same thing over in the Indian Ocean. It's supposed to be slowly making its way across the Pacific as well right here. West anomalies, making it to, where's the date line? The date line's right there, so about halfway to the date line in the Pacific into mid-June, maybe making it almost to the date line into the end of June. So this would be a window when there, maybe could be support for storm development. In this case, it would be the southern hemisphere. Now, the relationship between the MJO and the southern hemisphere in our summer is not as tight as the active phase of the MJO in the northern hemisphere in our winter, but still, it can support storm production. And then let's go out 3 months. Now, we don't believe most models out, even 4 or 5 days, much less 3 months. But this model actually does a reasonably good job. And this is the CFS model. All right. So the difference in this model, whole planet on one chart, Kelvin wave generation area starts right here, about 135 east to about 170 west right there. But this is past performance down here. The yellows are westerly anomalies, one would presume associated with the active phase of the MJO. The blues are easterly anomalies associated presumably with the inactive phase of the MJO. Now, a month ago, the presence of yellows and oranges was very strong almost over this entire area. Now that we're getting closer to it, you see it's a much more spottier pattern, but clearly westerly anomalies forecast to the date pretty much along this line, filling the Kelvin wave generation area, but just not particularly strong. Let's overlay the MJO, see how close we are. Okay, so we thought this would have been an active phase of the MJO with the yellows. It is. The solid lines are, solid red lines are the active phase. The dotted is the inactive phase. So the inactive phase is moving out of the Kelvin wave generation area today. There's the date line again right there. Active phase building in the west, forecast to traverse the Pacific through and the Kelvin wave generation area through about July 9th or 10th, something like that. So this would be a good spot for swell production. Then there's supposed to be an inactive phase, a short-lived inactive phase from July 10th to about the end of July. But notice, westerly anomalies still in control in the Kelvin wave generation area and continuing for the most part through the end of the model run. That looks favorable. What's driving all this? I mean, normally, you know, in no other presence, if you had an inactive phase in an ideal situation, you should have easterly anomalies. But we overlay the low-pass filter here. So the solid contour is just like the solid contour in the low-pass filter is just like the solid contour on the MJO. It's indicating low pressure. So low pressure, and you notice it's moving from west slightly to the east and then stalling and backtracking a little. So today, the low pressure bias is in half of the Kelvin wave generation area, right about 150 west. That would explain why we have westerly anomalies in half the Kelvin wave generation area. And you can literally look here and see just to the right of this line is nothing but solid easterly anomalies because we have a high pressure bias over, well, this winter it was filling the Pacific. That is the hallmark of La Nina. So this is like the La Nina indicator. And you see the La Nina indicator, the high pressure bias, collapsing and out of the Kelvin wave generation area completely by about July 9th, and then holding over like just off the California coast. What we really want to see is the low pressure bias fill in this gap and fill into the Gulf of Alaska. I mean, the Gulf of Alaska goes to, you know, about 125 west, so somewhere like over in here. When that doesn't happen, then high pressure will probably reign supreme in the Gulf of Alaska, and that's what it looks like is going to happen. They call it the ridiculously resilient ridge or just massive high pressure. That also means not a lot of rainfall, but I mean in August in California it doesn't mean a whole lot. The issue is this pattern going to hold as we get into October, November, and December, or is the low pressure bias here going to finally make a nudge off to the east? We're hoping it will, given drought conditions, given the potential for fire in the fall. We need the low pressure bias to budge. But the other part is La Nina typically doesn't run in a 1-year cycle. It's more of a 2-year cycle, and suspect that just getting it to make it to the date line would be a gift. All right, so the MJO is like a 1 month out into the future discussion. Now let's go out into longer term. La Nina, will La Nina continue? Clearly we're in La Nina now. NOAA has said it's officially dead. We tend to agree. There's some things going on, but are we going to move to El Nino, or are we just going to sort of sit in this netherland of neither El Nino or La Nina? So that's what we're going to discuss now. All right. So we're looking at ocean temperatures, not the surface, but down in the ocean, down 100, 200, 300 meters. This is the West Pacific here, East Pacific here. Again, data from the TAO buoy array. These little X's are what we're looking at. These are the anchor lines on the buoys that are holding the anchor lines that are holding those buoys in place. The X's are sensors on the anchor lines. They register temperatures at different depths in the ocean, send it all up to the buoy that's bobbing up on the surface that has an array on it that bounces it off a satellite that sends it over to Maryland. Maryland takes all the data, but mashes it together, runs it through a model to fill in the gaps, and then you get a profile of sea surface or subsurface temperatures, all right, in centigrade, 28 degrees centigrade. This would be 29. The reds, you just look at it and you go, a lot of warm water in the west. But the good news is there is warm water in the east now, too. The 28-degree isotherm is at about 165 west. I think it actually made it to 163 west earlier this week, so it's backtracking a little bit. But all winter it was over at, I don't know, it was somewhere around 180. It might have even been, west of there. So warm water has started moving to the west. What's that mean? Well, if you're in La Nina and trades are very strong pushing out of the east to the west, it takes all this warm water, balls it up in the far west Pacific. When trades relax, then that sort of suggests the end of La Nina. Warm water starts flowing to the east, not in a steady stream, well, sort of, and not on the surface, but under the surface. So that's what this is. Anomalies, differences from normal for this time of year. The 0 degree line means perfectly normal. 1 degree above normal, the whole way to the surface, filling the West Pacific, into the East Pacific. 2 degrees above normal, almost 3 degrees above normal in the far East Pacific, is indicative of a Kelvin wave pushing from west to east. That's what you want to see. This winter, it was nothing but cold water, below normal temperatures over here, that if you don't have enough, below normal temperatures don't support evaporation. Evaporation supports precipitation, and precipitation is what you want on the equator, because what happens on the equator dictates what's going to happen far to the north and far to the south away from the equator. So wetness in the East Pacific, south of California is, precipitation is a good indicator of rainfall pushing into California in the winter months. So, and to start all that, you have to have warmer ocean temperatures in the East Pacific. So we see what appears to be the start of that. In fact, there's another chart here. Put that right there, and you can see it even more so. There's a little bit of cold water here in the far East Pacific. That's the last lingering remnants of La Nina being squeezed out by this ball of warm water that started limited over here and has steadily moved its way east. Kelvin wave, it's actually 2 Kelvin waves trying to make an impact, trying to erupt in the surface in the far East Pacific as we speak right now. Sea height anomalies. Okay, so let's get oriented here. This is a hard chart to read. South America right here. Peru there, Chile there, Central America there, Hawaii, where is it? I can't even find it. Oh, there it is, right there, Hawaii. The equator, right there. Dateline right there. New Guinea there. Australia there. We're looking for ocean heights. This is strip out the wind waves, strip out the swell, strip out the tides. Is the sphere of the ocean higher or lower than normal? What we see right here is slightly above normal. This is 0 to 5 centimeters. I mean, what's 5 centimeters? That much or something? Above normal from, well, Ecuador, the Galapagos right there, there. This was one, I think last week, it was one continuous 0 to 5 centimeter pool the whole way across the Pacific. It's kind of broken up with this update, suggesting that maybe the Kelvin wave is losing a little bit of energy. But it is still there. Let's continue on. And here's another model view of what's going on. Upper ocean heat anomalies. This is the upper 300 meters of the ocean. West Pacific here. East Pacific here. June 2020, a year ago. The blues, colder than normal water temperatures. You see it. This was, and the peak of La Nina here in November. You can see a very clear pattern. Cold in the east, very warm in the west. Trades nuking, okay? If you have cold water in the east, that supports high pressure. High pressure in the northern hemisphere circulates that way. In the southern hemisphere circulates that way, creates strong trades, blows all the warm water into the West Pacific. Then somewhere around February, the active phase of the MJO pushed over the Kelvin wave generation area, which starts at 170 west. So, somewhere along that line. Warm water, Kelvin wave number 1, pushed the whole way across the Pacific to 90 west. Kelvin wave number 2, another active phase of the MJO in like the March-April time frame. Warm water, and this is where we're at right now. Not quite making it to Ecuador, making it to about the Galapagos. We want to see this erupt to the surface. Warm water subsurface does nothing. It has to make it to the surface. It has to then enhance evaporation, and that in turn is what will change the atmosphere, the global circulation at the jet stream level over the Pacific and then around the planet, and then that sets us up. So El Nino, La Nina is a planetary phenomenon, if you will, weather cycle but it's driven mainly by what happens in the Pacific, and looking at these temperatures here is key to understanding where we're going to be in the future. It takes a long time and a lot of energy to move all that warm water the whole way across the Pacific. Likewise, it takes a lot of energy to get you in this cold of a pool, this sort of a situation. So we're moving in the right direction, but we're not there yet. All right, continuing on, the all-important ocean surface temperature data. South America here, Chile down there, Peru there, Ecuador there, Galapagos there, sort of a split image. Mexico, Central America, California up in here, Hawaii right there. All right, the equator, we'll use this bottom image right here, 0. Okay, warm water off of Ecuador over the Galapagos. The Kelvin waves that we saw, they only go 5 degrees north and south of the equator. So there is generalized, we'll call it neutral, to just barely warmer than normal water almost the whole way across the Pacific. But we do have the last little bit of cold water upwelling off of Peru and sort of radiating off to the east from that last little pocket of the La Nina cool pool. Okay, then we have generic cool water south of the equator, and yes, ocean temperatures have been very cold in California, but they're much better, at least up in Santa Cruz, better now than it was even about a week and a half ago. It's like almost semi-normal, but you can see this big plume of cold water and warm water here. So what's going on? High pressure. The core of high pressure, there's dead air, no wind right there. But then out around the edges, you get this circulation, the strong northwest winds that just been nonstop making wind swell in California and upwelling. Okay, so there's the delineation of the high pressure in the northern hemisphere, and much the same in the south, though it appears to be a little bit more elongated here, but the same sort of deal. So remnants of La Nina still in control. No real signs of El Nino coming, but at least signs of a return to a semi-normal pattern. We just need to really tamp down this blue area right in here to get us to maybe where we'll get a better evaporation pattern. Again, California, it's right down here south of California and probably into the interior southwest U.S. So right in here, this is the prime area we're looking at to see warm water buildup just to get some hopes for precipitation for this winter. And it's got to hold for months, okay? But at least we're better than we were last year where this was all dark blue. Sea surface temperature trend for the past 7 days. Well, pretty neutral off of Peru. Yeah, just a tiny area cooling around the Galapagos, a tiny area of warming south of California, but pretty much everything neutral. No clear sign. Yes, it's getting real hot here. That's all high pressure and just dead air. That can change in an instant. All it takes is one big cold front swooping through there and a little bit of upwelling. But it's the equator that is the key thing to driving the global ocean circulation. Also notice a lot of warming here in these islands. If you get the active phase of the MJO passing over here, some of this warmer water will weasel through all these little cracks and crevices and then start spilling into the West Pacific. If the active phase is strong enough, then that sets off your Kelvin wave cycle. Just a little tidbit there. And then the overview, nothing new expected here. Slight warming along most of the equator, slight cooling south and north of it. So we're in this remnant La Nina state, not moving towards El Nino, but at least trying to get back to normal, but not quite there yet. Sea surface temperatures, actual temperatures in the Nino 1.2 region. That's the area right there by Ecuador and the Galapagos. Yeah, we had a little spike in temperatures about 0.6 of a degree above normal back in March, but then it's been cold or cool somewhere around 3/4 of a degree below normal and hanging. No real change as of late. But it's the official El Nino region. At least NOAA says this is the influential region. The Nino 3.4 region, which runs roughly 170 west to 120 west, which is just, south of California out to the date line. Temperatures, this is a noisy area up here. This is more of a steady state area. And you can see temperatures clearly returning to, as of today, 34 thousandths of a degree above normal. So basically dead zero, and has been there since the beginning of May. So again, this return to normal, but no, you have to be up in here a half a degree above normal for 5 consecutive 3-month periods to be in El Nino territory. So we're not in El Nino. We're not in La Nina like we were down here. We're just kind of neutral. We want a little more energy pushing us one direction or the other. That seems to really feed energy to the jet stream. When there's the big swings, when you're just kind of in this laconic, steady state thing, the jet stream really doesn't get energized. It doesn't do a lot, and that doesn't do anything for storm production. Continuing on, we're almost there. The Southern Oscillation Index. All right, so we talked about the MJO thing, right? Then we talked about subsurface ocean temperatures. Then we talked about the temperatures on the surface, right, and their effect on the atmosphere above them. So let's go look at the atmosphere. What does the atmosphere think is going on? Difference in pressure between Darwin, Australia. Darwin, we'll say that's, over the Indian Ocean. Tahiti over the Pacific Ocean. When low pressure is over Tahiti, the index goes negative. Today, minus 10.78. So, and we've been negative for a couple of days, so indicating, well, maybe the building active phase of the MJO, right? And that's what we want, right? Looking in the past, well, it's been pretty positive. There was the last little bits of a last active phase back in May, but the bulk of May has been positive numbers, inactive phase of the MJO. 30-day average takes all the noise out of this. Today, positive, 4.38. We want to see negative numbers, but notice that the index is falling. We were up at 7.65 in mid-May. So it looks like we're moving towards the active phase of the MJO. The 90-day average is the El Nino La Nina indicator. This needs to be negative, pretty negative to be El Nino. Today we're at 1.59, so like dead neutral. If this were, I think we were up at plus 15 or something. You can see, well, you can't really see it here, but at the peak of La Nina back in late October, November, we were at plus 15. So to be down at 1.59 is, hey, that's good news. We're almost neutral. Clearly, the index is falling, but we need to be down at minus 15 for it to be El Nino or lower. We're nowhere near that. We're, again, just returning to normal, it looks like. And here's the 30-day SOI graphed out just so you can see. Back in 2019, negative numbers. We were in some sort of weak El Nino state. We weren't down at minus 15 yet for a minute or two, but on average it was like minus 7. And then this January 2020, you almost could see the beginning of La Nina happening as the index moved more and more positive. It peaked somewhere temperature-wise in the late October time frame, but according to this, it was January of this year when we pretty much peaked at La Nina. Then active phase of the MJO, 2 Kelvin waves, and now see, here's another active phase of the MJO trying to set up. We want to drive this guy down into the negative territory, or at least get him at neutral so that the atmosphere can get back to a neutral state. But it looks like we're heading in the right direction. The sea surface temperature forecast from the Nino 3.4 region from the CFS version 2 model. All right, so where are we? We are just about at the beginning of June, which would probably be right about here. This shows temperatures, sea surface temperatures, still about 0.2 of a degree below normal, but we know that we're pretty much actually right. So this is a little bit biased negative. Temperatures forecast to get dead neutral in June, July, and then start a downward trend, getting to half a degree below normal in October, November, and December, and then start a return to normal from there. So we wouldn't call this a double dip La Nina, but maybe a return, according to this model, to a little bit more negative temperature trend as we get into the fall and winter. That does not bode well for, if you have negative temperatures, then again, you got the evaporation issue, you got lack of precipitation coming into California, lack of snow, and this also sort of indicates probably not a super strong storm track for the coming winter and fall, and certainly not a good precipitation forecast for California. So keep that in mind. So that was one model's view of the outlook. This is, well, you can count all the models here. Was it 25 or 30 different models? Some dynamic, some statistic. They all have their strengths and weaknesses. The dynamic average, the CFS model is a dynamic average, but the dynamic average consensus as we get out in September, October, November, December, January, dead neutral temperatures. That's pretty good. The statistic average is basically the same deal, dead neutral. The CPC consolidated, though, suggests something more negative. So how does all this play out? Let's go look at some of the models here. So this is the average. We're not going to go through each of these, but this is the average of the dynamic models, their water temp forecasts. You can look at dead neutral. The statistic models, pretty much dead neutral. Average them all together, dead neutral. So according to this, and where's the CFS model? It is a dynamic. CFS version 2. Here's its forecast, right? And you can see it's kind of, here's one that says +1, +1.5. This is full El Nino. So all these models are all over the place, but you put them all together and says, well, maybe neutral. We tend to favor the CFS model. It's just my opinion. It's a guess. I mean, everyone's entitled to their own opinion here. So we suspect this might be biased a little bit high. I don't think we're going down to half a degree below normal like this model suggests, but maybe a quarter degree below normal as we get into fall. So maybe, just maybe, that won't have too negative an impact on the long-term outlook. And then one last little bit of data, the Pacific Decadal Oscillation. So this is like a super long-running El Nino, La Nina. And I'm not going to get into all the details here, but the reds are warmer, wetter patterns, the blues colder, but notice the time frame here. So right here was 1998, right? Big El Nino, 97, 98. Another big El Nino in, 82, 83, right? But you see prior to that, there's this long-running cold spell. Then somewhere around 75, 76, we kind of went into a warm phase. And then with the 98 El Nino, clearly we dipped into a cold phase. We thought with the El Nino of 2014, 15, 16, we were maybe coming out of it, but we're becoming more predisposed to think we're still in the cold phase. This last cold phase here ran from the late 50s. I mean, maybe I can, there you go. There's a cold phase if you ever want to see one. It ran from, the 40s to about 75. So what is that, 30 years? And then we went 75 to about 22 years of warm. And then in 98, we're already in, 22, 23 years of cold phase, and maybe a bit more to go. We were hoping this had kicked us over into the warm phase. We're thinking maybe not. And if that were the case, then that would sort of bias us towards, remember we talked the low and high pressure bias? Well, there's yet another bias that nobody really has a handle on yet that might say that maybe in the Pacific we're still going to stay cold for another 5 to 10 years. Unknown, who knows, but just something to sort of keep in the back of your mind. So for right now, there is some swell in the water from a gale previously that pushed under New Zealand. Not big swell, but from a decent direction for Northern California, and it has made waves. Today's probably the last of it, maybe some dribbles tomorrow, and that's it. But another swell on the way, very south angled, probably favors Southern California and select breaks in Southern California the best for the bulk of the coming week. Then after that, you look at the models, just absolutely nothing. A long-running flat spell. Hopefully wind swell will fill in the gaps, at least north of Point Conception over on these shores of the Hawaiian Islands. Little bit of northwest swell coming into Hawaii this week too. Nothing huge, but rideable. Make the most of it. And maybe a little bit of southern hemi swell in the mix there too. After that, while we're looking at the MJO thing, we're hoping to eke out a normal fall. It's kind of early to say. We're still in the spring unpredictability barrier for what, another 2 days? Come June, you're out of it. The model should have a handle on things. The CFS model has been completely unwavering in its suggestion that temperatures are going to get colder on the equator as we get into fall. That would suggest a not great but not horrible winter surf season. We'll keep an eye on that. We'll keep looking. And beyond that, 10 years out, well, who knows? But some of the models suggest we're still kind of in a lackluster pattern for a while. So we'll just have to figure that out. Anyway, if you enjoyed the video, give us a thumbs up. Comments, please write there on YouTube, and we'll reply, hopefully pretty quickly. If you haven't subscribed, please subscribe, ring the bell, whatever it is, and we'll send you email notification. If you don't want to do any of that, that's fine. Go to stormsurf.com. Almost all the data that you've seen tonight is available there, and you can sort of look around during the week, follow the models, and then test your knowledge with the video on Sundays, typically when we do the video. And then if you have questions about how we came to whatever conclusion we came to, put it in the comments section. We'll have a discussion about it, and we can all learn together. All right, so go surf. There are some waves. Have fun. Make the most of it, and stay safe. And we'll see you next week. Same time, same channel. Thanks for watching.